trepidation. Were people okay with the morning session? Was the information valuable? Was it useful?
Very useful.
Okay, because it's we had good participation, which I was very pleased by, and I saw people writing it down. But sometimes you never know. People might be thinking, "Oh, why am I here?" So good. Okay, we'll try and continue. We'll try and continue on in that vein. So we did have a discussion this morning just about the general principles. This morning, as the secondary session, I believe that we had two topics that we were going to dive into in detail. So the first was logging, and the second one is ship-to-shore transfer. I did schedule some time, but I think that we can be a little bit more. We can be a little bit more loose with it. So we did talk about the diversity of logging solutions earlier in the morning, that people had developed their own particular software packages. It sounds like a common pattern is to have a web-based front end and plugging into a database backend. And the other consistent point is that at some level you want to be trying to leverage existing vocabularies. And this did touch into the larger picture of at least trying to use the NERC vocabulary server. There may be opportunities for some sort of standard place names. Are place names under the NERC vocabulary server? I'm not sure if they are or not. But if not, it might be something worth thinking about.
They do have some place names, but they haven't got control of the gazetteer.
Yeah.
Which uses the majority, well, most of the majority of the land based.
Yeah. So that may be something to consider if you're. But then again, we may just end up reverse coding that from latitude and longitude in terms of approximate location. But in terms of logging, I think that we've talked about the technologies, but this is where I'll open it up a little bit and say, what would people like to see in terms of logging? What would you like it to do? What are some of the pain points that you're encountering? So again, we're focusing specifically on that logging aspect of things. Or conversely, we can say, what do you find is working very well? But hands up, who deals with logging software here? Anybody? Okay. So I'm going to put you on the spot, Nils. Sorry, as the first night you have to fight. So what would you like to see in terms of logging software?
So at the moment we use EARS, and the issue there is that it's not difficult to use, but it requires some explanation.
Mm-hmm.
And when that is missing, or you don't find it immediately, the scientists that you or want to use it, they give up and use something else.
Mm-hmm.
Or when in order to use it, you have first select the program that you're currently working on. Mm-hmm. And if something went wrong with the transfer of the online database of available programs, and they don't find their program, it's not usable. Mm-hmm. So they stop using it and switch to something else. And that's one of the difficulties that we have. At the moment, we don't have remote access to the vessel. So if something happens, it can be a very simple thing that went wrong, but I cannot access the vessel. Yep. So there we have some issues.
Yep. So documentation is an issue. Ease of use to some degree is an issue. Bandwidth constraints are an issue. If you don't mind me asking, what is it that people fall back to if they can't use the software? What is it that they do?
I'm not really sure. I think most Excel or just all the electrician who is there, they write sometimes and they ask what is the
Yep.
I'm not 100% sure. But
so Excel or handwritten notes, and then they would probably hand it over to somebody expecting that, well, do something with it. And so this ties in with your earlier point. I would expect that probably the reason that people are turning to Excel is that it's something that they're familiar with, something that's easy to use, but what it does is it displaces a lot of the effort probably onto the people who have to deal with it later and have to develop that interoperability, who have to be able to do that reusability. So it is this consistent pattern of easy for you, but then you just put the problem onto somebody else to deal with at a later time.
To solve some of the problems with the views, we now, in the new version, we include the manual in the web interface, so it's easy accessible. We hope that that would solve already 80% of the difficulties, that it's just one mouse click away, the instructions, how they need to use it.
And I do know that it's easy to ask, but one of the hardest things is to develop a really intuitive user interface, where you just, because I know people often don't even want to click and read the instructions. They're just like, I should just be able to fiddle it out and fiddle with it and figure what it is. And if not, well, I'll go back to Excel because I don't need to read the instructions for Excel. But like I said, the issue with that is, sure, Excel may be quite familiar, but you lose all of that interoperability down the line. So we need to incentivize people. Other things going on with logging? Questions? Yes.
Just a quick remark from my experience. Leading bridges themselves. Usually, I've always found that the logging software that we were using was better when it was sort of merged with the planning software.
Yep.
So that you've got your plan and you've got your logs, and you can really interact between the two, and it makes the discussion with the bridge when you're discussing operation much easier as well. They know what you want to do. They know what you've done. Everything goes in the same place.
Yeah.
Quite useful.
No, that's an excellent point, because something that I know that we have to deal with in the Australian context is that our logging software doesn't only get used by the scientists, it gets used by the bridge as well. And we also have to deal with the bridge and the technical comms officers. So to have something that's broadly understood and broadly accepted by not only the scientific staff, but also the operational staff is key. And so this also does tie back into the vocabulary elements, because there may be scientific vocabulary elements, but you need to be able to capture something that's relatively easy to use for the ship staff as well.
Well, I'll go on that point.
Yep.
Different users of the logging system. When we've created the systems on the St David and Attenborough, the key use case was scientific research. But many of the things, as you've just alluded to, that we acquire for scientific purposes are also very useful for shipside operations. And while the crew and officers have ways of feeding back, it was never the primary means. They have their own navigation systems. But what we have found, and one of the observations I've made, is that because we've got quite a lot of flexibility with the data logging systems we've got, and we can respond very quickly to changes with data visualization and data access, is that as time's gone on, we've been asked to create things for the ship's side, because it takes them longer to get it done, let's call it the official route through the refit process, and go into the manufacturers of the equipment to change their, the bridge visualization software. And care has to be taken that I often find I'll do something, or we will do something, and it's just for best efforts. And then you'll get, as I got this weekend, an email from the captain saying, it'd be really good because we're pretty much relying on this visualization now.
Operational creep.
I was never there to create the navigation system for the ship, but it creeps, and suddenly it becomes ship's navigational safety, and that is. And
I've seen this pattern again and again and again, where something works and something works relatively well, but it was designed on best effort, and it does start to creep into operational use.
And I've made it worse by making the change that was requested.
Yes.
The cycle just loops back around. It's like, oh, brilliant. I can
Mhm.
email on a Sunday and it's fixed.
Yes. Excellent. So I'll also open up the question, what are some of the things that people use logging for? I mean, obviously you can use it to understand scientific gear deployments. You might be able to talk about, you may be able to use it as a form of impact in terms of impact reporting. We've done these sorts of activities, and this relates with particular science projects. But I really do just want to just canvass the room. What do people use the logs for?
So just, David mentioned this on one of his previous ones, and he's just reiterated it now. Are we talking about underway data logging, or are we talking about contextual event logging?
I was probably,
The two, but
yes, correct. So I was probably talking about event logging.
okay.
So that's what I was intending on discussing in this section. So I would probably preserve the other logging for the OpenRV DAS discussion. So that would be my answer, David. I hope that's okay.
But we're doing that with the same system.
Well, event logging, I guess, yes, some people do, but what I was reading from the room before is that many people have many different systems for the event logging, whereas for the systems logging, there tend to be more cohesion around using OpenRV DAS, except for the case of the Sir David Attenborough, where they were using their own particular system. Is that fair or no?
Well, I take Taco's point that there is an overlap between event logging and because the sensors themselves can tell you when events have occurred, sometimes better than humans can. In fact, an endpoint would be that all contextual events actually come from sensors eventually, as a more reliable medium of data than humans that are making observations.
Yep. So let's make sure that we record this as a potential point of distinction, that we do need to distinguish between event logging and system logging, but that they are not mutually exclusive. So let's make sure that we record that. But I would say, understanding that distinction, if we were to draw the Venn diagram, I would be talking about event logging and also the part where it overlaps with the system logging. Would that be fair?
Not the one who said it's not fair, but
No, but this is part of the discussion.
in the systems that I know,
Mhm.
so the system we are currently using and the previous Texas and casino system,
Mhm.
was actually that there is a continuous logging of all the underway
Mhm.
instruments, and then every now and then there is some human intervention
Yeah.
where the staff on the bridge enters
Yep.
information or timing actually from,
Mhm.
okay, this is an activity going on CTD casts or something else.
Mhm.
So it's more the bulk of the data collected is from the underway sensors.
And I agree. And
And then every now and then, in the same system, some other information is entered, and then you can filter that and get this station log or whatever you
Yep.
want to have.
So
It's essentially one system, not that much separated.
So what I would probably say is, in terms of the system recording, I would probably, again, save that for the OpenRV discussion. But what I would separate it out is, rather than talking about at the system level, I would probably differentiate it into sort of the more automated system, which we'll call the OpenRV DAS discussion, and the human mediated systems. And so I think that's sort of what I'm thinking about. Is that a fair distinction? Okay. So in terms of the human mediated systems, again, I'll come back to the question of what would people be looking to get from those human mediated systems, or should it just is the only thing that's valuable the automated information? Is there value to the human mediated systems? Yep.
Well, I'll just put out what we're doing. So our systems are somewhat separate, but they're getting more and more combined. But we use event logging for kind of two large separate suites. One is shipside and one is for our like ROV systems. And that especially the ROV event logging is significantly different and has a variety of both marine technicians and the scientists in terms of scientists doing science and creating templates that are going to be specific to biology or geology. And those are the data points that are going to be sent to repositories later, and they're being hand event logged into our system, as well as technicians saying, you know, the system went overboard, it's on bottom, it had a power failure or things like that. So there's definitely a mix in there. But I do think that one of the large issues was kind of touched on is we wind up having to make the system so flexible for every type of system that's brought on board, or for us biology, chemistry, all these needs, that it can break quite easily. You need to have people with software capability to deal with it every time. So it's very flexible and it works very well, but then it's not as automated to get that information out every time. So how do you handle this? And you've touched on it many times, this issue of having something that can be used for so many different processes and not lose data and information along the way. And likewise, we've had a lot of requests for scientists to have, like, can they play with it prior to coming on board, because they don't want to read the documentation. It's a lot easier to just play with a system, see how it works, and then be able to use it straight away. And so that's something we've been working on, is can we have a test suite, not just of our event logging, but actually of all of our systems in the cloud, both for software development purposes, but also for scientists to be able to use.
Yep. And I don't know, it's getting late at night for Tess. Tess, are you still online?
Oh, yes, yeah.
Hey, Tess. You look like Dave Connell for a moment, but
Oh, God.
what I was
kidding,
what
Dave.
I was going to say is that one thing that we have on our end is that we are able to have particular event items added by users. This does run some danger of duplication that Alex was talking about before, or uncontrolled terms. But Tess, do you want to speak to sort of the notion of how flexible the event logging system is that you've been working on?
Yeah, sure. I also have some more questions about the Schmidt Oceanographic Institute one, because I've heard a lot of things about Sealog as well. So
Yep.
sorry if it ends in more questions.
That's okay.
ELOG is quite flexible, and we have at the moment which is also, sorry, going to end in a question for the room, but we have it broken up into systems which kind of at the beginning roughly reflect our final voyage data, like the top level directory. So, you know, we'll have an event log for CTD in the same way that we produce the final data set. We do also then in the actual forms, so while we're with CTDs, I guess we'll stay there, have it feeding in. So from OpenR VDAS, we'll have like it gets saved with like the sea temperature or kind of whatever parameters that scientists or end users or the technicians would like to see. So we can add those in and are quite flexible. At the moment, we as in my colleague Peter and I, the data officers, kind of do that on request because we don't necessarily want to show people the back end of our stuff in case they go crazy and then start making all these customized forms, and then that will really kind of spiral out of control. But yeah, we do work with the technicians trying to make it quite as useful for them as possible. I guess one thing there, which is kind of the question that I was wondering how other ships do it, is because we generally, like I said, do it per system, but we've had requests, for instance, from our acousticians for like just to have a giant like acoustic event in general, and then storing that in and then linking the instruments into that. But when you're working with the back end, that kind of, you know, this is that flexibility argument coming in again. So I'm not sure if that really answered anything or if I just asked more questions. Sorry.
So I guess what you were asking about is sort of handling sort of a larger event cluster, sort of.
Yeah.
So how would you end up dealing with an event potentially composed of other events?
Yes, exactly. So yeah, something that'll affect like the EK80s and the hydrophones, or like K-Sync, for instance, or all of those things, to have like a composite event feeding into those, and just how that's kind of organized on other ships.
So I'll open that up to the room. Has anybody worked with composite events or larger overarching events?
Could you define it?
So I think that she was, so Tess, what would be an example of something that would affect the EK80s and the hydrophones and something all simultaneously?
Well, the K-Sync, I guess, just has its own one. Okay, when we're doing
give you an
EK80 calibration.
So,
Okay.
Sorry, somebody I think has an example.
Give you an example. I mean, the uncontaminated seawater systems that most ships have, that they comprise multiple sensors that you can have your own equipment logs for each one. But oftentimes the things that affect one affect all of them, because something like the flow goes down, it affects all of them. So instead of having 4 equipment logs all saying flow stopped, instrument now, you know, recording stagnant water, you have a combined one that has your 7 sensors that are all part of a wider system.
Sort of a
So
tree,
there's an example.
sort of a reference tree.
We actually have
Yep. Oh, sorry, go ahead, Tess, and then
for
we'll
that
move.
exact example, that's why we kind of did keep ours, I don't think, yeah, on the top level. So our underway, autonomous underway, sorry, it is late here, so my words are a bit bad. Oceanographical, we have the Ocean Pack. So we just have an Ocean Pack event, and then people have to add in the sensors. So we have about 7 sensors in there. And yeah, we'll just tag the sensors that'll be affected by that water flow, because then, for instance, we have one of those sensors which is actually not in the actual Ocean Pack, so it won't get affected by water flow that happens there. But yeah, so we'll add it in like that. But it is quite a bit of a manual effort.
Yep.
Yeah,
Go
I
ahead.
think actually you just answered your own question on that one, because that's similar. Our shipboard event logger system, we do have a variety of templates. Some are very specific to one sensor system, but then we have these larger scale event values, and you might have like a drop-down menu where you can choose multiple sensors that were affected. So like sonar quality, for example, choose a few, but the data that we've chosen to pull, for example, from RVDAS for any event, it tends to be, we pull all data at that time across all sensors and log it for that event. So then you can go back and but then you're not saying specifically, oh, because this is a sonar event, I'm only gonna save this sensor data. So for example, if there's a sonar quality issue, I also have wind and current state and other things that allow me to look across and not have to go back and find that information separately. So we also tend to have like there's just a free form event you can add, but we tend to have a combination, but we do add templates every cruise almost. And so I think it winds up, it does get to a point where you have to review and say, do we still need all of these templates, or are
Can
they
you condense them?
coalescing on something? And and actually go back and say, what are the questions that we're actually trying to answer here? And think about it from that point of view.
And sometimes I would expect that the questions would probably evolve over time. So as you begin needing new templates, other templates may drop away as, you know, capabilities are replaced.
Yeah, and I think that at least from my point of view, in terms of the architecture, I try to think, you know, what are the things we're going to be able to go back and get, even if it's not in the event log. So all those data pieces, are they in a database somewhere that are going to be accessible by time? So, you know, even if we don't have them in the event logger, are we okay? Versus what is that basic hand information that we really need to ensure is always there and accessible, but can link back up.
Yeah. And I guess, again, this is the distinction that I make in my mind, and not everybody will, but you have these automated systems running, and then you have this superimposed human layer that then links to it. So that may just be an artifact of, you can probably tell that the Australian approach is been forked from the Schmidt approach, but that doesn't mean that it's necessarily the way.
Could you give an example? Because I don't understand. What kind of events that you didn't log but can reconstruct afterwards? I mean, how does it work?
I'm saying that in terms of, like, you don't need to type in what the temperature was or, you know, the wind speed, but you can pull that information from a database with a person saying, we saw a bird hit the sensor,
Yeah.
you know.
Or you may have had a human whale observation or some sort of wildlife observation, and that would be a manual event that could then be tied back to the automated systems, perhaps.
But also in terms of sensors going down, one thing that can be hard to, you know, do from an automated point of view is, did someone turn off the sensor or did the sensor fail?
Yeah.
And from an automated point of view, that's not always obvious without a human hitting that they actually physically went and chose to turn off a sensor.
I mean, that is the main reasons why things happened is the main use of humans, other than humans as sensors. Like whale ops, you know, where is the sensor?
Yeah, but it's where the machine is unable to make that distinction.
Eventually, if you get enough sensors,
Yeah,
you'll have the cause and effect element.
yeah.
So the things that the humans can add are the things you don't have sensors that are monitoring for.
Yeah, and this is the case of, you know, as the technology evolves, it probably will coalesce to not needing needing very little human intervention. So you're ahead of the curve, Taco.
Because for things like many of our events are filled with start and end of deployments. Mostly you could back that out of the data itself. You can tell when the CTD goes into the water because physical properties change. It's not easy, but it can be fairly well automated. But you know, if you then say, well, actually, that's difficult, we'd prefer an observation. If you have enough cameras around the ship and an automated use of extracting information from that, again, that all those elements could be automated. But yeah, I agree that the reasons, especially if it's reasons that are not to do with the sense themselves, it's human reasons that made it, the conscious decisions have been made to do a thing one way rather than another. That's very difficult to.
Yeah, and point well taken that, you know, in the event of system sort of failure, or all that you'll know is that something went wrong, you won't know what went wrong or how to divide it up.
Well, yeah, if all of your power goes, then you are reliant on the human writing it down on a bit of paper, put it in the event log afterwards.
Yeah.
Excuse me, I just joined. My name is Webb Pinner.
Hello, Webb.
Yep, I'm the one responsible for the trials and tribulations that Crane has with the Schmidt event logging system. I wrote it, and I didn't realize logging meant event logging. I apologize for joining late. And Tess, it was really nice to put a face to the name. We've been communicating many times over email, and I'm suffering from the exact opposite. It is way too early here. Yeah, but to the point about event logging, that is the human element is, of course, the big challenge when it comes to event logging. And the system that's deployed on the Schmidt boat, we did our best to kind of design a system that was that deals with the human element. And by doing that, we left the system as loose as we could to allow for the most variety of ways to interact with the data by various humans and by automation. That particular system has a pretty robust authenticated backend API. So you can submit events via templates. You can submit events just by typing in a field. You can actually write Bash scripts and Python scripts that submit events. So like if you wanted to do like automated deployment detection, you absolutely could pass a program a file, and then at the end of that program's execution, it basically submits a start and an end. The association of the event with the ship's data, as Corinne outlined, is through a database. And the way we set up that system is any event that is submitted, it knows that it needs to go out to an InfluxDB and pull X, Y, Z fields. We can set up that particular subroutine to actually change the fields that it grabs on a per event basis. So for instance, if you're dealing with an ROV or a CTD, something that's deployed, something that you really don't want to know what it is doing because it's irrelevant, because it's not in the water, we can program our system to only grab the relevant information if it's actually applicable. So if it is a sonar event, or if it is a seawater event, we could make that particular event only grab the seawater systems, or only grab the acoustic, status systems and whatnot. We tried to do our best there. The system also is not dependent on real time. So for instance, and we've had to fix this because sometimes a sensor goes down in one way that affects being able to put it in event log and real-time dashboards, but not in terms of being able to save it to file. And so the C-Log architecture actually, because it's the full API driven, we can actually back populate ancillary data like, position and anything really. We can back populate that at any time. We can also submit an event at any time for any other time. So we can say, it's like, hey, we forgot to mention, we did an XBT 3.5 hours ago. We can say XBT, set the timestamp, and the system on the back end actually uses that timestamp to pull in the ship's actual data values from that real-time database for that moment when the event is timestamped. And so that just gives us a lot of flexibility to not be beholden to having to do everything in real time, because we all know going to sea, when things get chaotic, stuff falls off the table. And so we built that particular system so that it's as flexible as it can be to support the reality of trying to do event logging at sea.
No, that's great, Webb. So a couple of points on that. Certainly everybody appreciates the amount of work that has gone into it. So there's certainly no argument from anybody here in the audience. We're really just trying to get everything out on the same page. So just again saying we appreciate the work that's been done. So thank you.
Oh, absolutely. I apologize if that introduction had already been done. So
no, it's all right. So to tie back to an earlier point, Webb was talking about the importance of being able to retroactively go back and change parts of your logging system. So that sounds like we've heard that before. So in terms of a requirement for logging systems, that's an important feature to have. Okay. Yep. Frank.
I have a question.
Sure. Yeah.
Some people have demos, but at the moment it's all like logging what happens on the ship, but what's happening if you have an AOV or an ROV in the water and they do their own thing while things happen on the ship?
Yep.
So do they have their own event log, or it's like an event?
So right now it sounds like Schmidt does.
Yeah,
but
in
go.
our case, we use a different flavor of C-Log for the ROV because it really is much more scientifically involved with observations that the scientists are seeing, and there's a lot more to it. And this is a point Webb and I have talked about quite a bit. Like, as you get more and more deployable systems, do you use separate loggers? But then we also log in our ship-based system, general information about ROV was deployed, but in terms of like actual events related to the ROV, it's in a separate ROV event logger, but then all the data itself is together, but in terms of reporting and event logging, it's a bit separated.
Now, I also have a question. Do those ROV events, do they tie into, for instance, image annotations
Yes.
for? Yeah,
Yeah, so that's a whole other kind of topic we haven't really touched on, and it's another place that we're trying to move pretty quickly in, because scientists do wind up using event loggers as image annotation for speed and ease, along with other things that they're doing. And we actually tested this year integrating that into Tater, which is a real-time and post annotation, scientific annotation software platform. So we actually streamed live the ROV video from the ship or from the ROV to shore, and allowed scientific annotators to, in near real time, do scientific annotation and then add the sea log events to it as well, so that they could use those events to go in and do more annotation after the fact. So this is a huge area that we're working on to try and bring all these systems together.
yep. Taco? No, okay. Because this, again, I'm familiar with the sort of annotation space as well. And many of us have been talking about the increase in AI and the increase of AI to be pulling out patterns. And those annotations are prime candidates to be pulled into artificially intelligent software. And again, we come back yet again to the consistent pattern of, you would probably want those annotations to be presented in a consistent way using consistent vocabularies. So I would come back to, let me just move this down. I would come back to the premise that for all of these applications, probably if nothing else coming out of this room, we should probably try to develop some sort of conventions on the vocabularies that we would like to be using as the basis for a lot of this. So
I would just add to that at least, because image annotation is kind of its own thing, that the large scientific annotators for image are Squiddle, Tater,
Yep.
and Beagle all have built-in vocabularies and schemas into their software as well. So it's an area that's like more highly evolved, I think, on that side. It's all feeding into now FathomNet and other platforms for labeled imagery.
Yeah, and I know Ari from Squiddle at least, so this is probably something that I could raise with him in order to find out what's going on. But yeah, just to be aware of these different pieces. No, so that's a good question, Frank. Again, reflecting on the human mediated event logging, are there other things that people have questions about or that you think need to be addressed better? None? Taco?
Perhaps just about in a different direction. For our cruise planning, we use marine facilities planning, which is also used here in the UK.
Yes?
And I think in Norway, but I'm not sure about the and we import information on the cruises, including information on the instruments which will be used during a cruise, imported into our event logging system, so that automatically the right sensors, the right sensors, instruments, and information on that particular cruise is ready before the start of the cruise, and all the probably chief scientists and the crew on the bridge have to do is enter the order of the instruments being deployed.
Yep. Now, I'll say that within the Australian Antarctic Division, we've taken up using marine facilities planning as well. So it does sound like, I think Cyro is using MFP. So be aware that this is another area of people starting to pick up the technology. Just by show of hands in the room, whose programs are using MFP? So Susanna is using them, Taco is using it. And are you using MFP here?
Despite the fact that we're all NERC employees that BAS don't currently use it, other than through duress.
Okay.
Marine ops folk do put them on because the outline, but we're not using it in the same way that NOC.
So do you have any analogous software that you're using?
We have a system called South,
Okay.
which is our planning system that includes all of the station operations as well. So this comes
Wow.
to one of these
Wow.
one of these universes that has a bigger universe outside of it.
Yes. Yes.
And
Okay.
hence why it's difficult, not impossible, but difficult for those that are in the ops team here to fully commit to something which is a
Yeah, and it's a
marine
significant ask
planning
to,
tool, because the interplay between the marine and the terrestrial-based operations and air-based ops is complex.
okay.
And obviously some of that would be lost, that complexity would be lost by moving to a dedicated marine platform.
Yeah, no, understood. Yeah, go ahead.
Question for those who do use it. I'm curious how difficult it was to set up, or what the system is for setting up that. Is there an API of pushing or pulling data?
To my understanding, there is.
So it was relatively easy to use.
I'll speak to our experience. I wasn't the one using it, but I certainly knew the person who did. He seemed to think that it was relatively easy to use, relatively easy to set up, and our group has actually been pleased with the outcome. I'm not a salesperson or anything, but our group has been quite pleased with it. But one thing that we also do recognize is that we haven't been pushing it in any way, shape, or form. We're kind of using it as it was intended to be used. But I know that there are ways of developing and building modules. And so I was wondering about the degree to which we would be able to have some sort of interface between the MFP and the logging. Obviously, Taco, it sounds like you're doing that already, but how challenging it would be to use that in other systems.
Yeah, I'm curious too.
Mm-hmm. So, and if we, if we ended up converging in terms of these human logging systems, it might be a little bit easier to either develop a push-pull solution or talk with the organization that develops MFP in order to do that. Because I think they are open to building. Good questions. Anything else that people have concerns about on the logging front or on the event logging front? I'd also turn back to potential uses. So we do try and want to get an inventory of the activities. Any other uses that people would use it for? Yeah, Susanna?
Yeah, we use the event logging system to create onshore to automatically generate the metadata XML files.
Oh, okay.
through Python scripts. And with these metadata files, we feed our repository and
So you
we
connected to,
update- we upload this metadata to CDataNet. The infrastructure.
yeah, so that's good to know, because you would be able to
Yeah.
then, as opposed to needing to go through all of it, you have an automated way of saying, these are the particular activities that were done. That's interesting. And the other thing that you then might think about is if you've got MFP, which was your plan, and then you've got what you actually did on the ship, you might be able to align it with, okay, this is what we thought we were going to do. This is what we actually did. And it doesn't have to be a 100% match, but
It's normally quite different.
and that would be interesting in and of itself, because often when you're applying for funding, people assume, well, this is going to be what exactly happens. And if you end up saying, well, 70% of the time, it's not exactly what happens, you need to factor that in.
So that is a wider use of event logging. So we've talked a lot about equipment, event logging, sensor, event logging, but the onward reporting. So, effectively it's a future event log that's been put into the marine facilities planning, and you've got events based on whole cruises, so start and end of predicted start and end of cruises, things like that. I do get quite a number of requests now to designate periods of time on board the vessel by various activities. So this isn't to do with equipment, this is to do with whether the ship was transiting versus logistics versus something else. And there's a whole set of overlapping vocabularies that are ill-defined about those activities that are going on that aren't happening, at a particular second. They're spanning weeks or months of time.
Yeah.
But there is a requirement for reporting those kind of things, and they do, while they don't match exactly with the sensor templates and things like that, they are effectively a start-end type situation, so they fit in very neatly into event logging software.
And this is the sort of conversation that I wanted to tease out, or sort of thinking more broadly about it.
And the issues we have there is that oftentimes different people believe a vessel or a autonomous vessel, whatever it is doing different things. It means different things to different people at oftentimes at the same time, simultaneously.
Yeah.
So, someone on board the ship might think that it's transiting, but actually it's stuffed full of underway sensors that are always recording.
Yeah.
So really it's doing science.
Yeah.
But what is it doing? It depends who's asking the question, what the answer needs to be.
And it's this paradigm of you do it once and multi-purpose many times. In this case, it's different prisms or different perspectives into that single activity. And so, being able to take that core package of information and filter it out in different ways. Yeah, it's an interesting question.
We do, this is Webb again, we do something
Yep. Hey,
with
Webb.
that so one of the other platforms that's wired up, not quite as complexly as Falkor, but close, is Ocean Explorer 1, Ocean X's research vessel. And that's a ROV dual sub vessel, deployed small boat with its own multi-beam. And coming back to the earlier thing on event logging, every platform runs its own independent instance of CLog. That's how we handle that. But on the reporting side, they, for the subs, they need very detailed reporting to meet class certification. And they actually, to automate that, we actually use CLog and some additional information, and we actually have CLog at the end of the dive generate a class compliant report that they can submit directly. We're in the process now of doing the same thing for the vessel, where between the data that's stored in CLog that can be pulled from its API and the data that's in the ship's data management system, we can actually build a kind of 85% cruise report automatically just by accessing the APIs available from the ship's data logging and event logging systems. That's then presented in a document format that then the human element can go in and write a summary of, anything that wasn't captured with the automated systems, and any explanation as to why something, why did we do this instead of this? The cruise plan was to do this. And so that's kind of the way that we're on that particular vessel. We're trying to tackle the reporting aspect and the documenting of here's what we tried to do, here's what we actually did. And it's working.
That's excellent.
Yep.
Go ahead. Go ahead, Webb.
Oh, no, I was just adding, just kind of adding to on the reporting side. That's something that I'm seeing used on that client. Schmidt does use the same kind of technology with Sea-Log to generate post-dive reports from the vehicles that include things like your major statistics in terms of bounding box, max depth, cruise track or dive track, depth track, vehicle health, number of samples collected. In the past, we've used that same architecture where with an ROV, we'll have a samples report, and that samples report will actually be formatted in a way that it can be printed out, they can run out on deck, and it's already kind of set up for, you're going to pull this sample from this section of the vehicle sample tray. Here's a picture of it. Here's a space for you to make notes as you pull it out of the basket. We're having a lot of fun with that. And that's using a project called Report Lab, which is kind of like a Python-based LaTeX. And so it's really easy to go from machine readable data structures like JSON or whatnot, and kind of write a script that gives you a really robust PDF report, because it can pull in Matplotlib and GeoPy and all these other great tools to build you a really robust and very fast automated report.
No, and that's fantastic. I mean, I think that all kinds of people are looking for ways of being able to generate those human readable reports. And so again, to sort of recap a little bit, we've sort of started converging on this theme of beyond the immediate event log, its use in reporting, in comparison to planning, and also, as Webb pointed out, being able to use it to inform compliance as well. So if you need to do permitting, or if you need to show that your vehicle is fulfilling certain objectives. So that's something to think about, is that's how you can use this information, and how we can help to automate that into these reports, collect it once, but then filter it many times. So again, I think that was a very useful segue into a topic. Is there anything else that anybody would like to add to that topic? Yep.
Right now, if I'm kind of summarizing,
Yep.
I see that there is a difference and an overlap in planning and execution of cruise plans, in manually entered events or automatically entered events.
Yep.
In human measurements and sensor measurements.
Yep.
In samples which will be analyzed later on, and data which will immediately be digital.
Yes.
In cruise reports and event reports. The question is there also a difference between polar things and generally oceanographic research vessels in this case, with all these overlapping differences in mind? Is there something specifically polar in this list?
I don't think so. I don't. Despite I have to avoid hanging myself here, standing in front of you in a polar vessel data workshop. Although I think that the polar vessel data workshop was to connect the vessel data with the polar community in a concentrated way. But I do actually agree with you in your point that we're not unique in this case.
It's not that I don't want us to be not unique. Is there something we're forgetting?
Yeah.
Is there something which the polar environment, difficulty which is added by the polar environment to things we are discussing?
Yeah, because it's a good point, and I'll sort of talk out loud. There is the sort of impact on sensors, and there's the difficulty in acquiring Antarctic data, but that doesn't impact the system per se. I would say, there's different subject matter expertise, but again, that's separate from the system per se. I think if you were a cynic, you could say, well, it's all zeros and ones in the end, and as long as you have it be have it domain-specific tagging, you'll be fine. So I'll continue trying to think through it, but I don't think. Oh, go ahead.
Well, I don't think that there's something uniquely different, but I think that the extremes help bring to light issues that we need to think of first as opposed to second. So connectivity obviously is
Yeah.
a big one that I think all vessel operators deal with, but it feels much more at the front with Polar, but I think that helps us
Yeah.
create these systems in a way that will work everywhere.
Just as you raised it, I thought that, yeah, it's probably because most of the world, maybe not so much the oceans, but most of the world is, as I said, moving towards this cloud-oriented, always on, always connected mode. Whereas, agreed, I think that a big difference is the isolation of the ships and the fact that bandwidth is not guaranteed and is often narrow at best, and that's not likely to change anytime soon. So the systems need to be designed with thin communication in mind. And modern cloud-based systems are built with thick communication in mind. So again, this is the example of when we're working with with our records management software. They're getting into a mode of, as opposed to shuttling documents back and forth all the time, they're getting into synchronizing deltas, very small deltas of information. And normally they wouldn't need to worry about it. It's just easy to not think about it. It's a couple of lines of code. But you can get the same effect with you can get a much narrower transfer, but it requires more thinking on the code end. So I think that, yeah, as a point of distinction, yes, as a point of distinction, it would be that isolated, unconnected nature of the Polar vessels.
Tessa,
Yes.
Tessa, go ahead.
Oh, sorry, Tess, go ahead.
Sorry, going back a bit, but to those that have MFP, does anyone use MFP, the APIs or the capabilities it has to generate their cruise or voyage reporting, or does anyone, yeah?
Does anybody use voyage reporting out of MFP? It looks like a no, Tess?
Noted.
Okay.
It'd be difficult to do that unless you actually put one of the issues with MFP is that people use it as a planning tool and then tend not to go and update what happens in reality. So it's only an approximation of what happens. So unless you put in a lot of effort, probably as much effort as the stuff that you acquired on board the vessel with your own event logging, you do the same work twice afterwards. So that's why MFP is a great planning tool, but I've not yet seen it as a great archival record of what occurred. I've never trusted it to tell me what happened in the past.
And it's probably, and being built as a planning tool, it's not probably meant for interactive, real-time updating, and
No, it could be used like that,
but it's not designed for that.
In fact, I'm not sure that in our institute that the actual cruise happened.
Mm-hmm.
It was planned.
You can say with 100% certainty it was planned. Yeah.
I want to add something about the point you made about the scope of the event logging. We've said that it's not really polar specific, and it's not really marine specific. Some elements of it, event logging could be used. The same kind of event logging could be used for any sensor, terrestrial, marine, air, wherever. But I should add that we when we put together some of the vocab terms, they did come from a marine space. So some of them in there are certainly marine focused. You know, you've got things like embark and disembark. That is something that's to do with vessels, not necessarily, you know, that's not the terminology you might use for going to or from a terrestrial station.
Yeah.
There are things like that. But it was considered that's why the marine element was taken out of it for those particular event process and event action terms. It ended up being platform event processes. It wasn't vessel, wasn't marine. So it could be used for
Yep.
frames, it could be stations.
And I think as long as you specified your dictionary and your and your term, it sort of ends up, yeah, but there would probably be some defined processes as well, but yeah, I think the main constraints probably come from the vocabularies that you're using. That's the
But the
principle.
scope probably should stop at research. If you look for event ontologies online,
Mhm.
pick up stuff in the marine realm, because we seem to be, as a community, quite hot on that. Event logging, you seem to hear it here, you don't tend to hear it as much in other realms, but the other things that you get online when you look for event ontologies are when the theatre performances are.
Mm.
So they're the two. So that's really kind of, forms of working out how to get that kind of information standardized out online, which now has been solved mainly by Google and others.
Yeah. It's a
But
big,
they're the two that you tend to.
it's a big improvised dance in both cases. That's the unique connection. Any last thoughts in terms of the event logging? Otherwise, we can probably transition into discussing ship-to-shore transfer. Are people ready to move into that? Okay. So to start off the discussion, we'll draw a line under that. Ship-to-shore transfer. We are collecting a lot of this information through various means. Let's assume that magic happens. It's all beautifully organized on the ship. We've already addressed that bandwidth is limited. So how do you end up getting it back to the archive, back to shore? So there are two paths. There is, if you have sufficient pipe, you can transfer things in near real time, possibly by satellite. We do this with our meteorological data because BOM is interested in near real time. And rather than having our Bureau of Meteorology go to the ship, instead what we do is we transfer the information once to the Australian Antarctic Data Center, and then we let people access it to their heart's content. So there is sort of this thin near real-time pipe. And then there is things like the large multi-beam collections that we've talked about, water column information, high intensity video, weather radar, that you're probably not going to be wanting to put through that satellite data pipeline. So I will admit that we're probably a little bit unique in this case. So don't take this as your particular pattern. We use AWS Snowball devices aboard the ship, which are essentially ruggedized RAID arrays. Each device can take up to 80 terabytes of information. We do have redundancy, but we have those aboard the ship. We use so TESS is responsible for making sure that our file collections are well organized in sort of an R2R-like structure, but then we use rclone. So rclone copies from our devices onto the AWS device. And so it's stored in an S3 type, using an S3 type container. And so what we then do is we synchronize our information onto that AWS Snowball device, and then we're able to pull it off the ship. Because we get our Snowball devices from Amazon, if the ship needs a quick turnaround, we can pull the devices off and put new ones on. If we need to, so then once we have the Snowball devices off the ship, we then take them to our local data center in Kingston, and we take the information off, and then we send both copies back to AWS, and we have a replicate there. We have the two duplicates to make sure that we haven't lost anything in the process. But that's in a nutshell what we do. Our data systems are based on using S3, so that's why this works for us. There is the possibility of building your own storage device, but the reason that we went with AWS is that A, it was ruggedized, but B, more to the point, we had to put it through our government systems, and they were interested in security. in particular encryption, and AWS had 80 pages of documentation and way more security than we would ever be able to think of. And I won't give away too much, but AWS were starting to get worried about people actually taking angle grinders and to insert foreign hardware into their devices. So they started taking precautions for what if somebody physically sabotaged their devices. So it's more than we would have ever done. So that in a nutshell is our process for getting things off of our ships. So we use these portable S3 devices. That's the way that we approach it. So now I'm gonna segue and put on the spot Schmidt, because I know that they have sort of a similar process. So if you would.
Sure, yeah, it's almost identical. There's some, small pieces in there. One is that we're using Google's infrastructure. Yes, so similarly, we have a Google Transfer appliance that everything gets loaded on the ship. We only use one, and we have backup systems on the ship, and we keep all the data on the ship in a backup copy as well for at least 6 months. When it's transferred off the ship, the difference is we send it directly to Google from the port where it's taken off, and then they upload it. One thing I will note is that not every country allows certain encryption devices everywhere, so you can't ship from any country. So just something to note there. And then similarly, all the data is put up into the cloud buckets, and we have archival versus more accessible buckets there. But so that piece is quite similar, I would say, almost identical. And then in terms of the near real-time pipelines, this is something we've been working on, and I think this year will advance a little bit more. We do have, and I think Webb might talk about this, we've built a small system to send our meteorological underway data to Samos daily in a mailer. But we also are looking into mirroring some of our database systems at a lower frequency in the cloud in near real time, so that we can use that for visualization. And then I have a separate pipeline that I send data by the minute to a Google Firebase database to make available for visualization purposes for the public. But we're going to look this year into there's some new algorithms for compressing data and sending it to the cloud from the ship to see what we can do to get more data off the ship in real time. And then we do stream at lower level all of our video data to YouTube via satellite, but the raw video is taken off via appliance.
Okay. Do you want to speak to Cyro's experience?
Yeah, so I guess ours is pretty similar, but we've got our own
Device.
Data server, which is just a Dell standard server with hot swap SSDs. And we've got 2 of those, so our redundancy, and 2 back on shore, and then just swap in new SSDs every voyage.
Yep.
And then we've been working through some real-time transfers as well. So we've recently got Starlink on board, so we've been playing with that, and that makes everything a lot
Easier.
more achievable.
Yes.
So we found that we can do a lot more now, but not as a standard, because that's not part of our standard
Yep.
set yet.
Yeah.
It can't be completely reliable, but yeah, and we do stream some video back to shore, and what other things. But yeah, basically probably pretty similar.
Okay. Does anybody else want to share experiences of getting from ship to shore?
This is Webb. I can chime in on some of the things I've done over the last decade on various
Sure.
platforms.
Please do.
So I started doing the ship to shore thing probably about 10 years ago. That was kind of when I got into this, and that was pre-Starlink and almost pre-cloud. So we had to do things everything was kind of roll our own. In terms of backing up shipboard, yeah, we were building ruggedized Drobos and whatnot, and making copies for archive, making copies for the other customers. For the ship to shore stuff, again, we weren't smart enough in terms of being able to leverage things like Firebase and some of the AWS services that are now, all over the place and make life so much easier. We really were back in the kind of a roll our own days. And what we kind of figured out is we figured out workflows where the real-time stuff was relatively easy. I mean, unless they wanted to see the numbers change on their screen, it's real easy to dumb down a GGA feed or a WIN feed to get you, to go from megabytes to kilobytes. That's a relatively easy compression. And we facilitated that. We actually wrote mechanisms whereby as the file comes in, a compressed version of that is created and that's pushed to the cloud. And so we went from having to send 300 megabytes a day to sending a few hundred kilobytes. That made it really easy. We actually extrapolated that pipeline for time-stamped data. So for instance, if we wanted to send multibeam, well, it was easy enough just to, okay, here's your multibeam file, pipe it through a rasterization, build yourself a compressed geotiff or something like that, and send that up to a tile server or something like that. And so that's kind of the approach that we use, because the time series stuff is relatively very well. You can just sum it down. You can subsample it to get it down to whatever file size you want. But for the non-time series stuff, for the more complex stuff, things like frame grabs, things like multibeam, ADCP, stuff like that, the philosophy that we kind of adopted is we needed to distill the data down to information. Because in the paradigm that I was working most with, it was a telepresence enabled system. So the majority of our science party was on shore. So the whole ship to shore thing wasn't really a nice to have, it was a requirement for the ship to keep working. And so we had to adopt the philosophy of, okay, we're not sending data to shore. We don't have the bandwidth for that. We're sending information. We're sending just the bare information necessary to make an operational decision. Where we did have to send more complex data sets or more complex information, like detailed reports or whatnot, we set up systems on board that actually we could establish a priority queue. And so basically through a web interface, you would basically say, hey, these are the files that I absolutely want to get to shore, like priority 1. If you've got the bandwidth, after you're done sending the priority 1, start sending priority 2. And we're doing all this through rsync. This again was pre-rclone, but it's kind of the same thing that you were highlighting earlier on sending the delta as opposed to just sending the whole file if it's changed. Yeah. And so that was the kind of philosophy we kind of came up with, is we automated pipelines to distill information from data to make it smaller in the first place. And then we put it into a priority queue so that we could prioritize the order in which that information is sent on a regular basis. So basically the people on shore knew that every 15 minutes, the priority 1 items should be there. And as bandwidth allowed, the priority 2, priority 3, priority 4 items would get there if the bandwidth allowed. And so that's kind of how we did it. And then when we pushed it to shore, we pushed the data in the same format or the same directory structure that it was stored on the vessel. So when the cruise was over, we were able to just do a straight merge of our full data set that was on a hard drive, just standard SneakerNet. We were just able to rsync that straight over whatever we got off the boat in real time. And so that way it wasn't a reorganization, it wasn't some jumbled mess, we didn't get into a versioning war. We essentially filled in the blanks once we were able to get the physical media to the shore-based facility.
Yep, and I absolutely agree with get your data structures right as early as you can. Don't try and fix them in post. So yep, and being able to encode well in order to minimize that transfer, and we've certainly seen that as well in terms of prioritizing your queue. So if you have the ability to do that, then that's excellent. I realize that we're approaching noon. We did spend a lot of time talking about logging. Any last things that people want to add in terms of ship to shore transfer, or we might be able to recap when we regather very briefly. But we do also have Dave Pablo Cohn and Webb, as you can see, speaking to us about OpenRV DAS and OpenVDM. So you can't get closer to the source than this. So please take advantage while we have them. And it's great that they were able to be with us. So any last questions, or people look like they're ready for lunch? I think people are ready for lunch. Okay, let's break and we'll close off and we'll come back in, I think it's about an hour's time. Thank you, everybody.
Yeah.
All right, so thank you, everybody. I hope that you had a good lunch. Sandwiches were delicious. I thought that they were good. Certainly, for those of us who are at International Data Week, you've topped International Data Week. So I will also say we have 2 sessions coming up on Open RVDAS and Open VDM. We are very fortunate, as I said before, to be joined by Dave Pablo Cohn and also Webb Pinner, who are at the heart of both of these projects. And as you've heard us talk about, there seems to be a lot of convergence on using these technologies. A lot of work has gone into them, and certainly they meet a lot of the community's needs. So, we are very fortunate to have them with us. For those of you who read your introductory email, they did have some initial questions for people to think about who are using these software tools in terms of who is using them, how are they being used, what are some of the challenges, and to sort of think about it and be on the front foot as we go into these. I believe that when I had scheduled it, we had Open VDM first by Webb Pinner, followed by Open RVDAS, Dave Pablo Cohn,